you boil water to make coffee, you basically break intermolecular forces. So what are those? Intermolecular forces are responsible for physical properties like boiling, melting, density, surface tension, which happens in the surface of the between the water molecule, the surface of water, and solubility. For example, when you dissolve sugar in your coffee, you all basically break intermolecular forces. There are the attraction between two molecules. For example, I have HCl here. HCl. We know that there's a covalent bond inside the HCl because there are two nonmetals and make a covalent bond. But there is intermolecular forces between hydrogen in one molecule and H in another molecule. Between the hydrogen in one molecule and chlorine in another molecule. So here again we have covalent bond inside the molecule of HCl. This is called intermolecular force. Intermolecular forces are really weaker compared to the covalent bond and ionic bonds. You can see 16 kilojoule per mole compared to 431. So you can see they are much weaker compared to the ionic and covalent bonds. What are those? Dipole-dipole interaction, which example, the one subtype of it is hydrogen bonding. We're going to talk about it. Ion dipole and London dispersion. So from now on, when you see an interaction between two molecules, you can name them basically. You can say, okay, I know that's a dipole-dipole. I know that's the ion dipole. And you can be able to recognize them. So what is dipole-dipole? Happens between two polar molecules. That's really important. And for sure in the exam, I will have this in the questions. I will ask what type of intermolecular forces we have between the molecules or specific molecules. Between the polar molecules, I have intermolecular forces. You might ask, so how I know that's polar molecule? We have talked about it before. Remember when I talked about the Lewis structure and West pair? So let's go over them again. Polar molecule always one is more electronegative compared to the other element in the compound. So chlorine here is more electronegative. We know that from left to right, electronegativity increases. So chlorine is more electronegative, gets the partial negative, and hydrogen is partial positive. The same here. Chlorine is partial negative and hydrogen is partial positive. So the positive and negative, partial positive and negative, they attract to each other and they make an attraction. What about hydrogen bonding? So I can call it intermolecular forces, dipole-dipole attraction. So what about the hydrogen bonding? Is a special case of dipole-dipole. Let's see how this forms. It's between hydrogen in one molecule. Let's just keep it HCl. So we know that it should happen between two molecules. What about the other one? The other molecule can be fluorine, can be oxygen, and can be nitrogen. So one molecule, and there should be for sure fluorine or oxygen or nitrogen present in other molecule. That makes hydrogen bonding, and you can see that this happens between the two molecules. Usually, for differentiating between from the covalent bonding, we show it with a dash, and we know that each of these have a lone pair, and if so, they can have interaction between the lone pair of one molecule and hydrogen in another molecule. And the hydrogen bonding is more basically strong compared to the dipole-dipole. Let's see, and then hydrogen bonding happening usually in the molecular biological compound. For example, DNA, which is really important. We get some of our gene from our parents' DNA. So that's a really important concept. What about ion dipole? Ion dipole happens between an ion, for example, sodium and water molecule. So one should be always ion, the other one should be a polar molecule. A polar molecule. So you can see that there is attraction between them. So that's the ion dipole and interaction or attraction. So always ion present in one, and there should be a polar molecule in the other side. The ion dipole is the strongest of all of the intermolecular forces. So what about London dispersion are present in between all of the molecules. It happens between all of the molecules. Doesn't matter they are polar or non-polar. Okay. So, but if a molecule is like non-polar, it's the only attraction that we can find inside is the London dispersion. How this forms? Imagine you have a helium atom and you have another helium. So how this attraction forms between two molecules of helium? We know that the nucleus have a positive charge, and the electrons are around the atom. To make attraction between them, we have electrostatic attraction. We call it instant electrostatic attraction. Like for seconds, there is attraction between the nucleus, which is positive to electrons, and we have an instant attraction, and then they basically disconnect. Again, we have electrostatic attraction and then disconnect. That's the London dispersion between them. So let's just see what are the strongest to weakest intermolecular forces. Strongest, we know that's ion dipole. For example, NaCl2 in water, we make a ion dipole interaction. The next strongest is the hydrogen bonding. Do you remember? When before between the hydrogen in one molecule and FO and N in another molecule. We have the next would be a strongest would be dipole-dipole. For example, it happens with, for example, between two HCl molecule, two water molecule. So it should be polar molecules. The other would be London forces. It happens usually between all of the molecules, but in the nonpolars, for example, we talked about the helium. It happens between the two helium and is an instant interaction between them. Please go over these questions and we're gonna do it together.